methods that we've become familiar with, as developers, traditional SQL queries and, just keyword matching, right? As well as, some of these newer, like kind of more AI search techniques like semantic search, vector search. Your contextual data store should be able to support all of these functionalities. It should be able to, support these functionalities at millisecond latency, to provide the freshest, most relevant context, in as short a time as possible. And that's going to be, well, we think it should be we think it should be SingleStore, but we're a little biased. Zooming in a little bit more into what your contextual data layer is and kind of speeding past this, as I'm sure all of us want to get fast, get to the code and get to the, kind of the meat of the webinar here today as quickly as possible. Your contextual data layer is going to, depending on your needs, it's going to support, a semantic layer, which is going to provide, your data access policy, your governance. Which is going to kind of govern, the APIs that sort of serve your, your vector search, right? We're going to see today how to interact actually with the SingleStore kind of vector search capabilities via the LangChain APIs that are hooked up to SingleStore, which make it very, very simple to use SingleStore with AI applications. And not just semantic search, but also, table formats, traditional relational database formats. Those are really kind of the bread and butter of, most corporate, data models and data lakes. And we would like to be able to interface with those as well. So let's take a step back and let's talk a bit about what we might even need this thing called embeddings for. And now you might have mentioned, or you might have noticed that I mentioned earlier, really kind of two main kind of information retrieval techniques that we've seen emerge as dominant for RAG. And that's going to be both, full traditional lexical / full text / keyword-based search, which is kind of what you might imagine the Google search does, or hitting Command F or Control F on your keyboard does, which is really just matching the exact letters or words or phrases that you type out to letters or words or phrases in your corpus of documents. That's great. That's actually, we at SingleStore think that you don't only need semantic search, but also full text search to support, a really robust information retrieval RAG system. But how about this semantic search piece? What is semantic search? Well, that's really where embeddings come in. Semantic search is really, and it's both an old and new information retrieval technique. Old as in it's been around for a while, but new because it's really only become recently very popularized because of all of these Gen AI applications. And semantic search is essentially taking your query. So for example, if your user types in the word Python, right? And in your document corpus, there's a bunch of articles about, snakes in the Amazon rainforest named Pythons. And also, documentation about the Python programming language. If your user says, how do I use, the Python shell, right? Semantic search is basically saying, I understand the kind of meaning underneath what the user is asking, and I should probably return documentation about the Python programming language and not a Wikipedia article about, the, snake that lives in the Amazon rainforest. So that is what is meant by using embeddings to provide a semantic understanding of, the information that both your users supply and the information that lives in your database that you would eventually like to supply back to your users and thus their LLMs, so that their LLMs provide more relevant answers. One sort of wrinkle here is that embeddings are not only for text. We're going to be only working with text today, but embeddings are also for images, audio, video, really like pretty much any modality of data that you can imagine. There exists embedding models for that modality of data. And if you're interested actually in, you know, both image and audio search, I don't believe we have a video one yet. I would highly recommend checking out our webinar library on our website. I have done webinars on the past on that. And so I will leave anyone that is interested in sort of multimodal embeddings to go check out those webinars. Um, so yes, that's the kind of one wrinkle that I want to explain about embeddings before we kind of move on to how do we actually choose the right embedding model for our task, right? That's kind of the big question. That's why everyone is here today. And I wanted to, obviously this is a 1 hour webinar and we're not going to cover, the entire space, the entire academic space of information retrieval in this hour, but I want to give a few kind of guiding principles for how to choose the right embedding model. And we'll also get kind of our hands-on and look through some of these embedding model choices and think through some of these choices in just a minute. But really, you're going to want to focus on choosing the right model for your specific task, right? And your task could be any number of things. If it's, RAG, your task is usually some sort of semantic similarity. And that just means finding, chunks of text in your body of documents that are semantically similar to, your user's query. Or it could also be, your task could also be actually taking a list of retrieved documents, a list of documents that an embedding model has. Oops, sorry, I'm actually going to go and close the window. There's someone outside. Sorry, your task might also be actually going into your list of retrieved documents and re-ranking that list of documents to be more a more relevant order. And that's another sort of task that you might be trying to perform with your embedding model. A really great starting point for understanding what are the best models for your specific task is I believe it stands for Massive Text Embedding Benchmark Leaderboard on Hugging Face. Not to worry, we will actually be looking at this leaderboard in just a second to understand, how to even parse it out. This leaderboard sort of provides, a ranking of open source models available, for free of charge, although I would check out the licenses on each of those models to make sure that kind of matches your business's needs. And it ranks them based on a number of different performance metrics that we use to evaluate embedding models. And we'll actually get into evaluations in just the next slide. Finally, last sort of few kind of pieces of advice. Your context size of the embedding model matters quite a bit. We've seen kind of recently the explosion of the context window of, the newer embedding models. And that's all well and good. Like, embedding models can now claim to be able to fit, 32,000 tokens in their context window, right? Like you could fit, the equivalent of like many tens of like academic papers in a context window. But the question you have to ask yourself is, does that actually help me with my task? And oftentimes a larger context window is actually not what matters for you because you're actually trying to break up say for example, a PDF or a piece of documentation that you have written in your internal company knowledge base. You're trying to break that up into chunks, right? So that you can provide more kind of targeted and relevant context to the LLM. Maybe you're actually, searching through document by document and you're not splitting up your text, and your chunks of text are actually very large. And in that case, you may want a bigger context size. But the trade-off is that when you have a larger context window, you're going to get kind of less fine-grained detail when you're retrieving based on sort of particular facts or kind of nuances in the actual text. You're going, if you're, if you're embedding an entire book, you can think of it as sort of embedding the summary of the book as opposed to embedding, maybe a central theme or idea discussed in a specific chapter. And all of that depends on how you would like to return context to your LLM. So that's all going to be very specific to each of your use cases. And I'm happy to answer questions about, what sort of context sizes you might be interested in, but that's the sort of high level principle. Very quickly and very finally, you really want to think about whether you want to use an open or closed source model. We're going to be looking at open source models today. Obviously, we're looking at the massive text embedding benchmark leaderboard on Hugging Face, which is all open source models. The benefit of open source models is that you can, one, you can host them by yourself, and so you can keep kind of all the data on premises or in your VPC if you kind of run those embedding models for inference on your kind of hardware. And then also you can fine tune an embedding model and sort of squeeze a little extra performance out of it. And we'll talk about that in a little bit. And because you have access to the weights of the embedding model. On the other hand, closed source models like, the models available from OpenAI, from Anthropic, from Google, closed source models tend to be easier to get up and running with, to prototype with, because all you have to do is just provide an API key, and you're usually integrated into all kind of major like LLM frameworks. Although you'll see that's almost just as easy to get up and running with a Hugging Face model in the code demo we're just about to get into. And then the final thing with closed source models is that they can be very high throughput. So, if you're embedding millions of rows a second, you might want to consider using a closed source model, especially if you can't, stand up an inference cluster that can run those embedding models for you like right away. Great. So now on to a little bit about benchmarking. And benchmarking and evaluations, I believe, is going to be really key to unlocking and choosing the best fit model for your use case. And this is something that I've talked about a good amount in past webinars, but happy to expand on it today. You really want to create a benchmark, a ground truth, preferably hand-labeled benchmark on your own data, right? And we'll show a quick example in the code demo of how to do that. But it's really important that you understand what it is you actually would like to do with your data, what the kind of golden path or ideal scenario is on your data, have multiple examples of that, right? Because if you aren't even sure how, what a good embedding or RAG result looks like, then it's going to be very difficult to choose the best model for your RAG use case. You might, maybe you start off with a closed source model to kind of provide a baseline of performance. Closed source models are generally, very kind of generally capable. They're, easy to get up and running with, as I mentioned earlier. But maybe they're a little more expensive than what you actually need. And so creating a benchmark on your data and starting to begin this evaluation process, which we'll jump into in just a second, could save you, depending on your kind of throughput for embeddings, it could save you, on the order of thousands, tens of thousands of dollars, right? Because, these embedding models we're seeing cost money per token, and they cost money to, especially these closed source models, they cost money to embed, thousands, hundreds of thousands, millions of documents, right? And that money is not insignificant. Just a bit more into the specifics of how to do actual evaluations. We're going to be looking at these two metrics called precision and recall today. These are usually really good starting points. They're kind of the gold standard starting point metrics to evaluate in natural language processing. And that's basically, these two metrics are basically asking, one, for precision, how many of our retrieved items are actually relevant to our query. So, if we're asking about, Python, the programming language, and we get, um, you know, we get, let's say we have, 100 documents about Python code documentation, and then one document about, pythons in the Amazon rainforest. We retrieve two documents, right? And we get back, one document about, Python code documentation, another one about the snake in the Amazon rainforest. That's a pretty bad precision, because, out of all of these Python documents, we pulled one, but we didn't retrieve the rest of them, right? And so, actually, I mixed those up. That's actually our recall. Our precision is actually, in that case, going to be 50%, because, one out of two of our precision, or one out of two of our documents are relevant. But in the other case, recall, that's going to be pretty poor recall, because we only retrieved, one document out of, 100, and presumably we should have retrieved, both of those, Python code documentation documents. And not to worry if this is all a bit abstract right now, we're actually going to be looking at some more visual examples in code in just a second. Finally, embeddings is really going to be just one piece in your RAG stack. At every single layer in your RAG stack, from how you present the context to the LLM, to the actual prompting around how you actually present that context, how you rank the context in terms of relevance. That's where re-ranking might come in. Whether or not you fine-tune the embedding model, whether you provide few shot examples in the prompt. All of these pieces and strategies are going to affect how you, or they're actually going to affect your information retrieval performance. That's all those ideas that I just mentioned are sort of upstream. After you've created the embeddings and you retrieve the context, how are you actually going to piece those pieces of context together to the LLM? You can also think sort of downstream, right? That's going to entail, like, how are you actually going to be splitting up your corpus of documents for embedding, right? That's where the context window of your embedding model is going to matter. If you're kind of just maybe building a semantic book search app, right, and you just want to be able to recommend whole books, then maybe you want an embedding model with a really big context window, because you'd like it to kind of get the gist of the entire book, but you don't need anything more precise than that. But on the other hand, if you are, if you're building an app that helps lawyers like draft legal statements, and you need to go kind of line by line in your, you need your LLM to be able to refer to, legal kind of statements and cases line by line, then you might actually only care about a smaller context window. Great. So I have a little bit here about SingleStore, and then we're going to jump right into the code demo. SingleStore is we like to call it a database to transact, analyze, and contextualize data in real time. SingleStore supports just both row-based, in memory, super fast, query performance, as well as columnar row storage or columnar storage methods, which allow sort of bottomless storage. And we've also, since 2017, had vector search capability. So you can perform, your traditional SQL queries on SingleStore. You can, analyze. You can kind of aggregate your data and show it, in dashboards, in analytics on SingleStore, and you can also, perform semantic search, as we're just about to see. on SingleStore and power your Gen AI applications. I'm going to really quickly just skip over a few of these metrics here, though you can kind of see that SingleStore is industry leading in some of our in some of our deployments already. And I also really want to just quickly shout out SingleStore Notebooks, which is what we're going to be working on today. SingleStore Notebooks is the best way to get up and running with SingleStore. Best way to get code up and running with your SingleStore data. It's as you'll see, very quick to set up, very quick to connect to your database and sort of abstract away the kind of the obstacles that kind of get in the way of just connecting to a database. If you're just running locally in SingleStore Notebooks, it's just a few clicks and you can already be talking to your database. And you'll see just how to do that in a second. Great. Okay. Let's go ahead and take a look at our code today. I wanted to really quickly actually show everyone how to sign up for SingleStore. So if you go to the link for the AirPods or Meta Ray-Bans raffle, you should be able to reach this page. Otherwise, you can go to singlestore.com/cloud trial. And that's the fastest way for you to get up and running on SingleStore. We recently launched a new SingleStore free shared tier. So you can immediately be running on SingleStore, trying out SingleStore, and trying out some of these features that we're talking about today, with no upfront cost. But once you've signed up, you should be able to enter your portal and it'll look something like this. You'll be on the homepage here. And I believe every new account actually spins up a starter workspace for you. And so you'll be able to see also your free tier starter workspace that should be already spun up for you. But if in case it is not, you can go into this cloud tab, click group, and then create your starter workspace. And I already have one here, so I'm not going to create another. And once you've created your starter workspace, you can go ahead and get started with SingleStore Notebooks by clicking into this Develop tab here, going under Notebooks. And if you look at the chat, here, I'll just send in the, UT, could you actually send the link, the code link to everyone in the chat?
Oh, yeah.
I just sent it to hosts and panelists, but I don't know if I can send it to everyone else. Great. So in just a second, the code should be popping up in the chat. We'll also be sharing out the code over email after the webinar, so not to worry if you are unable to follow along just this minute. But you're basically going to go into your notebooks. You're going to import from file, and you can go ahead and upload the notebook that we've just shared out in the chat. And it should, once you've uploaded the notebook, it should look a little something like this. Let's see, here we go. Great. And this notebook is really just going to run us through a pretty simple end-to-end sort of example of how to evaluate our best fit embeddings and to choose the best model for our use case. Kind of just at the start here, we're just installing a few packages. We're going to be using the OpenAI API for just a really quick chat, though that's not at all necessary, obviously, if you're using embeddings in a non-chatbot use case just for information retrieval. That won't be necessary. But we're actually going to be using the LangChain library today. LangChain is a super useful library that SingleStore is integrated into. It's an LLM orchestration framework that basically makes it super simple to stand up and prototype and put into production a lot of these Gen AI workflows that we're seeing today. Embeddings, chatbots, loading in documents like PDFs, web pages, and so on. It provides a lot of really useful abstractions and libraries for doing all of those things. Now we're actually going to take a look at the massive text embedding benchmark leaderboard to understand more visually what we're talking about here. Now, if everyone can follow this link in the notebook, but if you take a look at the benchmark here, you'll notice a number of different things. First, you can obviously choose between open and proprietary models. These other models types, sentence transformers, cross encoders, bioencoders, I will skip over just for the scope of the webinar today, though I'm happy to answer more questions over email about that. You can choose your model sizes, but what's really interesting and what everyone should be taking a look at here is the kind of task that each model is specialized for. And you'll notice, a few of these may seem a little more academic, like bitext mining, which is the task of finding parallel sentences in two languages. But a few others, like this retrieval with instructions task, might be very relevant to what you're trying to do with your RAG stack, right? And that's going to be the task of finding relevant documents for a query with detailed instructions. Or, for example, the semantic textual similarity task, which is going to be kind of the more general task of just determining how similar two texts are, right? And then finally, the re-ranking task, which we talked about, which is going to be reordering a list of documents to improve their relevance to your LLM. You're going to want to look at each of these tasks and really be sure of which you're trying to optimize for. And then, as you look through this leaderboard, a few things to keep in mind. Obviously, model size and memory usage, those are going to be kind of very positively correlated. And that's, basically a proxy for how much your model is going to cost to produce embeddings. You'll notice that, as model size gets bigger, you start to notice generally better performance, although that's not always true. And so that's why I highly recommend everyone to kind of check out this leaderboard for themselves. You'll also want to take a look at the embedding dimension. And that's going to be important because your embedding dimension is essentially going to determine how big the vectors are going to be when you store them in your database. And so, if you have, a bunch of overlapping text, right, because your embedding dimension is really big, and you're, say, for example, embedding, a bunch of PDFs, then your kind of storage size is going to balloon much quicker than if you choose a model with smaller embedding dimensions. Also, you'll want to take a look at the max tokens, and we've talked about that before, so I'll skip over that. And then you can see a number of different metrics that Hugging Face ranks each of these embedding models on, and these are, I believe, task-based. So, if you are most interested in retrieval, you might look at, the retrieval metric, right? And you might sort by, the best models at retrieval. If you're interested in re-ranking, you might sort by the best models for re-ranking. But anyway, once you've chosen a model, and obviously you're probably not just going to choose one, you're going to evaluate multiple models. You're going to be evaluating closed source models and open source models. It's very simple to get up and running with a Hugging Face model specifically. You'll just need to install this LangChain Hugging Face package, import the Hugging Face embeddings library, and then you just provide the Hugging Face name for the model that you're interested in using. So today we're going to be using the Mixed-Bred AI large embedding model. It is somewhere on here. Probably skipped past it. Oh yeah, right here. So we're going to be using this model. No real reason why. It's just sort of the first model that stood out to me. Oh, that's right. It does have a pretty small model size, memory usage, and embedding dimension. So especially useful for smaller text chunk embeddings. And you can see sort of how you can immediately kind of get started embedding documents. We're not using these texts here. This is sort of just to show how we're going to embed documents. But now we're going to be looking at a kind of test data set and sort of understand, with a toy example, how to benchmark our data set against our test data set and really understand how a model is doing on our proprietary data. So I have here, just a list of car dictionary objects, with a name and a description of that type of car. And now we're actually going to go in and embed all of these, descriptions by, creating a list of LangChain documents. And this is sort of just a data model that LangChain has. You can follow this if you'd like or not. The most important thing is that the page content is what is actually embedded, and the metadata is sort of auxiliary to the document that's retrieved. The metadata is more so that you have additional information to show when retrieving the document, or if you're filtering, you can also filter by metadata. Here in this cell, after we've kind of loaded all of our information into LangChain document objects, we're just initializing our SingleStore connection, and then we're using once we've set the environment variable, which, with SingleStore notebooks is just as simple as using this single line of code. We can, in one line, create our embedded document corpus using the from documents method for SingleStore. And you'll notice we use our Hugging Face embeddings model that we've defined earlier here as our embedding model. We're also using the new approximate nearest neighbor vector index, which makes vector search milliseconds fast on SingleStore. And now we're sort of just going to show a few toy examples of how that retrieval actually happens. So, we can ask, for example, what cars are best suited for families? We kind of get a more generic response without the actual documents. And so if we want the documents to be returned to us, there's you can actually perform a similarity search on your corpus, with the query and the number of documents you'd like to return. And in this case, we're only doing semantic search, although SingleStore does support both semantic and full text search, which you can check out in SingleStore documentation. But you'll sort of notice, we're just searching, family car, sporty car. We see, the results that we would expect, a coupe, a minivan. But here's where kind of the meat of our evaluation is going to come in. And that's going to be in actually defining what are kind of relevant documents to a query, and then measuring our precision and recall for that definition of what is relevant for a query. So for example, if we're searching, and this is obviously all subjective. Hopefully everyone can sort of extrapolate to how this might be relevant to your own data set. If we're searching something like family vehicle, right? Maybe in our corpus, we're going to say that SUVs and minivans are going to be relevant documents. Those are going to be the family vehicles that we're most interested in. And then, sedans and pickup trucks are not family vehicles. And in that case, our precision is going to be in our retrieved documents, our precision is going to be 2 out of 4. It's going to be 0.5. And then, sorry, I'm just going back to the document here, or the list of documents here. If we also define, and I should have mentioned this earlier, if we also define, a hatchback as also a family vehicle, right? So in our case, the most relevant documents are SUV, minivan, and hatchback, right? And we've returned SUV and minivan, then our recall is actually a bit better. It's 2/3 or about 0.67. And then in another example, sporty car, if we return two sporty cars in our retrieved documents, we have a precision of 2 out of 3. But on the other hand, if we define a coupe, a convertible, and a sports car as a sporty car, and we've returned sports car and convertible, then our recall is 2 out of 3. It's 0.67 again. So this is a pretty toy, like kind of end-to-end example of how you might measure precision and recall for a specific embedding model on your proprietary data set. It's a pretty simple example, but hopefully, again, everyone can see how it extrapolates their data. Now, I'm happy to open up to Q&A. I'm sure I didn't mention that Akmal is actually in the background helping out with Q&A. So thank you, Akmal, for that. I've been yapping for about 45 minutes now, so hopefully we have some good questions that we can get into. Akmal, any questions that stood out to you?
Yeah, there's a question about the OpenAI, Alex. I think you're using that, isn't it? The OpenAI key for your notebook. Is it at the top there somewhere, right at the beginning? And I think there was a question, does it need OpenAI? Well, obviously in your example, it does, but I assume that the code can be easily customized. If you want to use something else, it should be relatively easy to modify to suit the requirements. I mean, the general flow and the kind of the stages that you've shown would be applicable regardless of whatever LLM you're using, I assume.
Exactly, and that's why I like to use LLM orchestration frameworks like LangChain. It makes it really easy to kind of drag and drop or drop in different LLM providers. And in this case, we're just using the OpenAI LLM to provide, an example of, just asking a chatbot to retrieve over your corpus of documents. But we're much more interested in the actual contents of those documents themselves and the performance of the embedding model that returns those documents to us. And so we're kind of moving on pretty quickly from that. In fact, you don't need OpenAI at all for this example.
Yeah, I know your favorite question, Alex. So Dino's asking about fine tuning. So you've got an analogy that you use about fine tuning. So please fire away.
Yeah. So I would say first, if you're interested in fine tuning embedding model, please do check out my webinar on fine tuning an embedding model. That's going to be a much more in-depth resource on how to do that. But just at a high level, what are the specifics of the kind of mechanics of that question? Is it asking how to do fine tuning, when to do fine tuning, why to do fine tuning?
Yeah, so if I give you the question from Dino, Alex, he says, any thoughts on fine tuning embedding models? Is this worth it? I think I would think so. So many to choose from, and it would be overkill. So he's got a very good point there in terms of that. It's great to have lots of choice, but then how to kind of figure out what's the best for your kind of particular problem, and it's without having to do immense amounts of research and testing. Is there something that would help for just be able to run this on a specific model? I think that's the gist of what he's asking there.
Yeah. So a few things. If you kind of, I would say that this whole process of finding the absolute best fit embedding model is really only going to make like a noticeable difference if your costs from closed source models or serving an open source model are like particularly prohibitive. Your costs from serving the first model that kind of does retrieval at a good enough level, right? Or if you notice that your model's retrieval performance, your RAG pipeline's retrieval performance is not so great, like just kind of sniff test, like you're chatting with the chatbot and it's giving you all these inaccurate answers because the citations that it's offering are all over the place, then you might want to actually look at your embedding model, evaluate the embedding model over your data set, right? Fine tuning is, you can think of it as the way to kind of squeeze out the last few drops from the towel once, sort of everything else has been wrung out. And so the lowest hanging fruit before you even think about fine tuning are going to be, providing a few shot examples in your prompt. If you're okay with stomaching the extra token cost, uh, looking at your embedding model, right? Are you using the right sized embedding model with the right context window, with the right parameter count for your embedding task? Like, are you using an overpowered embedding model and overpaying for your performance essentially, or are you using an underpowered one? And then once you've kind of looked at all of that and re-ranking, and text chunking, and different text chunking strategies, then you can think about fine tuning and sort of getting that extra last 5 or 10% in your performance. But I would look at the fine tuning webinar for all the details there, because we are running up a little on time and I want to get to as many questions as possible. Anything else, Akmal, that stood out to you?
I can't see anything else at the moment, Alex. I think the majority, let me just see if there's anything else.
Oh, Veda asks, are there any embedding models that let you control the size of the vector? So 32-bit floating point, 16-bit floating point, etc. So in general, no. Although you do bring up a very good point, and this is like kind of an active area of research in embeddings and information retrieval. There's this new method of embedding, or there's this new kind of class of embedding models called Matryoshka embedding models. And Matryoshka is the Russian nesting doll, where you can, you have like a large doll and you open it and there's a smaller doll inside and so on. And the way it works is essentially, the embedding, that Matryoshka embedding model produces, an embedding of maybe, say, 8,000 dimensions, 8,096. And then, depending on your needs, you can actually just go in and truncate that to like the level of precision that you would like, to kind of optimize for storage space. So you can, traditionally, you can't do this with embedding models. If you kind of truncate the embedding, then kind of lose a bunch of information, right? And your kind of performance at that point kind of goes all over the place. But Matryoshka embedding models allow you to, truncate to half the size, a fourth the size, a 16th the size, if you don't need results that are as precise and you'd like to trade that off for storage space.
Yeah, that's a great point. That reminds me, actually, there's some great free training on the deeplearning.ai website on quantization. So you're kind of shrinking stuff down, and trying not to lose too much information in the process. And on the the point there about Veda using floating point 32, floating point 16, not specifically on the embeddings, but on the SingleStore side, you can actually control that, yes, in terms of storage of the vectors. By default, it's 32-bit floating point. You can actually change it to something else if you want to, and that's part of the setting up the actual vector type within the table. So that might be something worth looking at. But you're likely to lose information, I'm guessing, if it doesn't kind of match what you're getting back. And that could be, that's obviously going to be troublesome for you going forward. So something to think about there.
Yes. So yeah, number of different ways that you can kind of optimize your embedding storage, right? Both looking at, the actual floating point accuracy of the numbers that are in the vectors themselves, and then also the lengths of the vectors themselves, or the lengths of the vectors, which is more of what I was talking about with the Matryoshka embedding models. Let's see, we got a question from Marwa, who asks, can we also calculate time of an embedding model for the evaluation? So really good question. I actually don't know the answer to that off the top of my head, though I believe LangChain has an observability framework called LangSmith, which offers latency benchmarking and like kind of latency measuring of LLM inference. And that's the first place I would look to see if it also offers latency measurements of embedding inference. I believe that those things are kind of the same base object in LangChain. So I don't think there's a reason in principle that you wouldn't be able to measure embedding inference latency or embedding inference time. But that's the first place that I would look. Yeah.
Yeah. I think the other point might be worth mentioning, Alex, and I don't know this enough detail. It's just something that I think I read in passing, but obviously these LLM providers also provide lots of additional. I mean, we tend to focus on just the embeddings, but in fact, there's a whole range of other things that you can garner in terms of the information about what's actually being generated and so on. And it's worth checking their APIs and their libraries to see what else is available. So LangChain is obviously a great place to start. I mean, it's, you know, it is one technology worth spending some time investing in and learning. But if you're going to go after a specific LLM, have a look at what the LLM provider also supports and check them out.
Yeah. I would definitely say also that, for open source models, especially lighter open source models that you're self-hosting, that's probably going to be the fastest possible inference that you're going to get. You can't get much faster than, running on your own machine, running a very lightweight model on your own machine. Though, again, maybe your machine's not able to handle millions of ingest or embedding requests a second. And that's where you might need to look at, throughput and a closed source model provider like OpenAI or Anthropic.
Yeah. Earlier today, just again, kind of tangential to this slight discussion, I came across an article that I'd saved a while back, is how to build an LLM in 60 lines of NumPy code. And I actually got it running in our notebook environment. And it uses GPT-2, which you can get from OpenAI in the back end. And it's pretty awesome. It's tight code actually works. And it's running quite well in our notebook environment. And you think performance will be terrible, but actually it's not bad, not half bad. I might write a blog post about it. So there we go.
Yeah, no, I mean our notebooks are actually very powerful now. I believe we're rolling out soon the ability to use GPU powered notebooks.
Yeah.
So that's something to look out for on the horizon. But I know we're running up on time here. So Yuti, do you want to close this off?
Yeah. Hi. So thanks for the webinar. I'll just pull out the required thing to close off, and thanks everyone for joining. So just quick notes before I announce today's raffle winner. So just give me a second to pull it. All right. Thanks, Alex, for the presentation. Thank you, Akmal, for joining. So I will just tell you that we have amazing webinars coming up. So on June 6th, we have Zapier Central plus SingleStore, full RAG agents. The link to that is in the chat. I'll put it again. And on June 10th, we have Beginner's Guide to RAG with Professor Tom. And on June 11th, we have How to Do Knowledge Graph RAG with SingleStore. And on June 26th, we have an event, Unfreeze Your Iceberg Data for Real-Time AI. If any of these topics are interesting to you, please RSVP right now. I hope to see you all there. And the announcement that everyone's been waiting for. Today's raffle winner, it goes to Pranay Chandur. He's the Associate Director of Data Science at Walmart. So congratulations and thank you for joining. And if that is not you, please do not give up. We are going to announce one more AirPods winner and Meta Ray-Bans winner by the end of the day. So if anyone who tries out today's demo or has tried it out during the webinar, please sign up at the link right now as well and be eligible and be entered to win. Thank you everyone for joining. Thank you again to the speakers that have given their time, and we really value your time and energy. Good night, good evening, and good morning to everyone, and have a great rest of the day. Take care.
Thanks, everyone. Thanks, Yuti. Thanks, Akmal.
Bye.